you probably already know most of what I'll be covering, but maybe not as much of like browser document object model and stuff like that.
Yeah, it's been a while since I did the DOM, and also I did a class yesterday on HTML CSS. And I'm curious if we could maybe combine our lessons. If we wanted to upload something to software carpentry or keep it for posterity.
Yeah. Are we live yet? Oh, we're live already. Okay. So I won't tie my shoes then. Okay. So, yes, as we already introduced, my name is John, and I have done some web development in the past, but it's been a little while, so I was refreshing a lot of stuff while doing this. The lesson today is going to be mostly focused on the front end programming of the web. So that's browser interactions. We'll cover how websites are structured, which is the document object model, or DOM. A little overview of HTML and CSS, because you need to know a few of those basics in order to get stuff done. And then an introduction to JavaScript, and we'll be using ECMAScript 2015, which is ES6. It's the latest standard, and most of it is implemented in modern browsers, and assuming you're using at least Edge, Firefox, or Chrome, or even Safari. So because the actual information you need to know to do web development can be quite large, there are a lot of specifications, and then you need to know about compatibility issues and stuff. I've outlined some resources right at the start. Mozilla Developer Network is kind of the best comprehensive documentation on HTML, CSS, JavaScript, related APIs. It's quite extensive. I've used caniuse.com in the past. It's good for looking up if things are supported by your browser. So for instance, if I want to see how browsers support ECMAScript 6, I can pull it up and see that the class syntax is supported by almost all of the browsers in the current one, and you can see relative usage and stuff like that. So that's a nice little resource if you're going to be doing more serious web development. I mentioned JS Fiddle, which is just an example of a site where you can enter in information in the website, like all the code for a website, and it'll compile it into and show you the result. There are other things like CodePen that do that, and then accessibility guidelines from the World Wide Web, the official World Wide Web org. So for tools, you actually don't need much to start programming. If you've got a browser and a text editor, that's actually enough. You can do a little more if you have a simple web server with a text editor, or just a simple web server. So for instance, I'm serving off of my machine right now to do the slideshow. This is an app I made as the demo, and that's just using a Python web server. And so those are all of my accesses to this as I've been developing. There are also developer tools in the browser. I'll show you how to get to those. And then you can use stuff like JS Fiddle if you want to share snippets and that kind of thing. For more serious work, you'll probably need Node or Node.js, which is the standalone JavaScript runtime, and NPM, which is packaged with it, is the package manager. So if you want to use any third-party libraries, you download them with that. I'm not going to be covering much with Node and NPM because it gets to be a lot of boilerplate and stuff. It's just a little more detailed. So let's get to how your browser actually deals with the website. So a website is separated into three parts. there's the content and semantics, the style and the appearance, and the behavior. Those are HTML, CSS, and JavaScript. Or the source files for those are HTML, CSS, and JavaScript. Those are the only 3 languages that the browser actually uses. Okay. So in the browser, the HTML and CSS are used to create the DOM, the document object model tree, and then JavaScript interacts with it. So you can inspect the DOM with the developer tools. So the easiest way I have to get to developer tools is just to right-click an object and click inspect. And so that'll bring up your developer tools. You can try that now. Oh, I should also say, if you want to follow along in your own browser, jlayden.github.io/webdevbasics. I'll do that. So to make that text bigger, I'm just going to go and paste that there. Okay. Good. Now, so when we look at the document object model, the tree, that you can see it when you're in the elements panel of the developer tools. And you can select different things, different elements. So if I inspect this element, it'll jump to it in here. So I just right-clicked exploring the DOM and then clicked on inspect. And then I can see that I've got an H2, which we'll see as a heading inside of a class. And that class is actually inside of a div, a division, which is inside of a body, inside of the body. Okay. And all of the information that's used to render the website is contained in the DOM. So for instance, we can inspect in a bit more detail, can see all of the styles that are applied to it, event listeners that are attached to it. Currently I've got a couple of ones to handle keyboard input. And then the properties where you can actually get into, start seeing the JavaScript that's associated with the DOM, the API. So let's just double check. Yeah. So you have child nodes. So the heading doesn't have any HTML elements that are children, but it does have text. That's a child. While the section, if we look at it, has in children has 5 HTML children, which are a paragraph, a heading, figure, 2 more paragraphs. Okay, and so when you're actually programming for the internet or for websites and the browser, most of your time will be thinking about the elements in the page and how they interact, because that's what's displayed to everyone else. I turned off notifications, but whatever. Okay. Yeah, so that should cover it. Other things that are in there are the tag names, class lists, ID. We'll see a little bit more about those things later. Okay, so that brings us to the HTML. Anyway, my brother's messaging me. So HTML stands for Hypertext Markup Language. it's like any markup language, it's really a way of adding semantics to text. That's the meaning of what the text is. It's based on SGML. It's not strictly SGML. And now with HTML5, which is the latest one, they've made it with the modern web in mind. So you have new elements like main, nav, section. There's also video, stuff like that. The syntax, I think a lot of people have seen snippets of it. You can have, so tags are in angle brackets. A tag name, or they always start with a tag name and then a list of attributes. So it's attribute name equals and then the value. You can have another attribute equals and then the value. The double quotes are optional, but you usually include them because sometimes the values can have spaces, and if you don't have double quotes around it, then it doesn't get parsed correctly. And then you can have a segment of HTML inside of tags. Sometimes tags will not, oh, and then the closing tag. Okay. Sometimes sometimes elements won't actually have a closing tag, they're just a standalone entity. An example would be a link or not a hyperlink, but a link element, or an image. And then comments, the only option for comments is exclamation mark, dash, dash, and then comments. You can't actually, there aren't actually block comments, so you have to put that symbol in front of everything and then end it with the closing dash dash, closing angle bracket. Okay. So the sample HTML document is actually this one. So this is the page source for the current app. If we zoom in, you'll see a bit more. There is, so it starts off by declaring that this is an HTML document. There's the opening HTML tag with lang, and at the end of the file will be a closing tag. There's head, which opens the head element, and the head element contains most of the meta information, like the title. I've got a description and author in here. The style sheet is linked to. And then these are scripts that support the app. Then you've got the actual content. Navigation with an ID. I'll talk about what an ID in class is. Here's a non-standard attribute, but it's used by screen readers. And then a heading, a paragraph, a list. UL stands for unordered list. LI is a list item. Then there's figures with figure captions. That's also HTML5, not HTML4. Links are done with A, which stands for anchor. So A, href equals, and then the link location. Okay. Now, the reason why this page doesn't look anything like what I actually have here is that I've imported my app script after the page and then started it here with a function call. So my app actually erases the HTML or the contents generated by the HTML and then generates everything using JavaScript and fills it in. Okay. Good. And so, yeah, as you saw, everything's nested in like section and body and the headings, just like they are in the document object model. Okay. Semantics. So the purpose of adding all of the tags is to describe what the text is actually means. So H1 is a heading, P is a paragraph, UL is an unordered list, A is an anchor, which is a link or marker in the document. You've got navigation and stuff like that. The semantics can also be extended because you can't cover all the bases with new tags with class or ID attributes. Classes describe what properties many elements might have. So if you've got a whole lot of sections that have the same classes or that describe the same type of object, they would be in the same class. Okay, usually use lowercase with dashes like red dash box. The reason for that is because of CSS syntax. Okay, and then to make a list of classes, you separate them with spaces. So this has both class hidden and class slide. If I look at the current slide, as it slowly loads, there, you'll see that I've got class equals slide, and it's the shown one. Okay, and so the style sheets are choosing how to render it based on those classes.
So the slide shown text is something that you are labeling and seeing in the first row?
Yeah, so exactly. So the way this actually gets used is if you look at the CSS word is actually right beside it. So I have dot is class. We'll see the exact stuff about this later, but slide, if it has the class slide and the class shown, then it displays it as a block. If I remove this, then I just don't have it shown. So what my web app actually does is it changes the class of the slide that's supposed to be shown to shown, and then the browser picks up the style rule to actually display it. I don't have to manually toggle show this element and don't show this element. I just toggle the class. So that's one of the main uses for classes. IDs or identifier is meant to be unique inside of the document. It's not actually, it wouldn't actually throw an error, but if you tried to get all of the elements with that ID, there's no way to actually access every single one. It will just give you the first one, if I remember correctly. Okay, and then I should say there are also other attributes, which we've seen, like href for links, and alt is alternate text and images. Okay, so as I've kind of said before, the reason why we provide semantics is so that the browser knows how to render and place them. That's done with the style sheet rules. It also describes what actions they can do. For instance, you've got video, image, canvas is a way of doing interactive graphics, SVG, because SVG files are just XML. Browsers actually render them using the same guidelines as HTML and style sheets. So you can actually create SVG elements in the document, in the DOM, and modify them the same way you would any HTML elements. That's actually how D3 works, data-driven documents. Okay, and then you have links, text input, buttons. So any forms that you enter information into, they're also described in the same way, and the browser knows what to do with those objects. And finally, for accessibility. So tools like screen readers can navigate the page better if you do this. Tabs and associated keys will work as expected. So I can actually demonstrate. So ChromeVox is a screen reader, and I don't think this will go over this stream. Why is my computer slow today? Okay, so the orange box that's covering everything is ChromeVox. Okay, and so what it's actually doing right now, although because of the video plugged in, my audio is kind of screwed up, is it's reading the label of each element. So and the label of each element is labeled by the heading of the slide. So this dot reads the title of that. And then once you switch slides, it actually starts reading down the contents of that slide. And so the reason why it's able to do that is because I've added in the actual semantics of the document IDs. So H2 is slide title 8. And then if I look at oh, come on. I created an exception somehow. And let's turn off ChromeVox because it's slowing me down. Okay, there we go. So if I look at this, then it has ARIA labeled by slide title 8. So the screen reader looks at this button. It says, it knows that its label is given by the element with ID slide title 8. So it looks at the contents of that element and reads it out for the user. Okay. So one little pet peeve of mine is a lot of apps, they don't think about accessibility at all. And it's important to think about that if you want everyone to be able to use it. So screen readers are the first step. And if you want more information about accessibility, I have a link to the kind of the standard place to read about accessibility here. Also other guidelines like how you select heading levels and stuff like that. Okay, so let's get back to HTML. Actually writing all of the semantics into your document is quite tedious. So a lot of developers will use kind of pre-languages such as Markdown to write the content. That can be formatted with a parser, which outputs raw HTML, and then you use the raw HTML to create your actual document. And then even with the content written in a nicer language, the boilerplate and layout is often repetitive. So you use templating languages like Mustache and a lot of stuff. So Mustache is called that because it uses a curly brace. And if you turn the curly brace on its side, it looks like a mustache. So those are designed so that if you have the same boilerplate on every page, you use the templating language to fill in specific information for the page, and then you can also use Markdown for like blog post contents and stuff like that. Okay. So let's get to CSS, which stands for Cascading Style Sheets. It describes the appearance of elements. So let's pull up this style. So the cascading actually refers to the way they're applied. some of the declarations cascade down the hierarchy to their children, like background. You can't think of many others specifically. And then the important thing is that the rule with the most specific selector takes precedence. So we'll see soon that you can have a selector that says take a paragraph or the first paragraph of a section with the class name slide, and then that will, for instance, apply those style declarations only to that element. Whereas if you have any paragraph of the section slide, then those rules won't be applied to that one. Okay, so the syntax is always selector, open brace, property, colon, value, semicolon, and a list of those, and then a closing brace again. The whole statement is called a rule. Each property value pair is a declaration. Okay, so the first part of a rule is a selector, and that's how you choose which elements it gets applied to. So selectors are, the most rudimentary one is just using the tag name. So for instance, a div p section adds, which isn't a standard HTML tag, but you could still use it if you want. Most browsers will handle that kind of thing. Then the class selectors are always preceded with a dot. So dot class name, a dot class 1 dot class 2 would be an anchor element that has class 1 and class 2. Okay. And then ID selectors start with a hash mark. So hash main nav or hash start button would be an example of an ID. And then just for the sake of mentioning it, the universal selector is star. So that's one that will match any element in the page or any element of any type. Okay. Selectors also have their combinators. So this is how you combine different selectors to find a certain element. There's descendant, which is just a space. Child is an immediate descendant. Adjacent sibling is plus. General sibling is tilde. And same element, if you're combining, say, a class name or an ID with a type of element, you have to make sure you don't have a space in between them. So the first one is div.redbox. That would select a div element with the redbox class. If you have div space redbox, that would give you a div, or that would give you some element with the class redbox that has a div somewhere up in its ancestry. But it wouldn't actually select the div.redbox that you want it to. Okay, you can, another detail is I tend to read these from right to left. So the rightmost selector describes the actual element you're trying to get, and then all of the ones to the left of it describe extra information about it. So for instance, H1 is the actual element that it's going to pick, but that H1 is going to be a sibling of a paragraph, which is the direct descendant of a section. Okay, and then that's going to make it blue. I can actually add this to the page. So if I go into sources, and the font size is huge, but okay. So you can, one of the nice things about developer tools is you can actually edit everything live. So if I go section and just going to close this off so it doesn't hide everything. Section T plus, we'll see if what I wrote is actually correct. Color blue. There. And I've made the combinators heading into blue. And technically I should put a semicolon after it. Okay. And if there was no actual paragraph element beside that heading, then it wouldn't be selected, I should say. Okay. There are other selections that you can do as well. That kind of gets really complicated, which is why I mentioned reference documents at the start. You can select by attributes, where you put in square brackets around the attribute name. You can ask for attributes with specific values, or if the value is in a space separated list. There are actually other things you can do with that as well. There are pseudo classes, which are preceded by a colon. So for instance, we can have a div that is hovered over. First child, first of type. So first child will select the H1 only if it's the first child of its parent. First of type will select the first H1 in some element. You can select all odd paragraphs with nth of type 2n plus 1. There are a whole lot of these. And then there are also pseudo elements, which are preceded by 2 colons. I screwed up the formatting here. But sometimes, so there's what you can do is actually have colon after, and then add in content to after an element, and that content can be almost anything. So in this case, we have, if the href attribute has HTTP in it, then after that link, put in an arrow to indicate that it's an external link. Okay. I'll just show you in this CSS file some examples. We have a content ID. We have a section that has the class slide. We have something that's in class slide has the show all attribute or class. We've got the first child, a paragraph that's the first child of a slide. That is how I'm drawing the CSS in gray. And then stuff with the navigator. So one of the things in the navigator is all of those dots at the top are buttons with the class dot, and then when you hover over it, it changes the border color. And you can see that if I hover over it, it changes it to black. Okay. Good. So also in CSS, oh man, there's so much to cover. CSS has declarations, which are properties and values. Common properties are color, background, display, stuff like that. Again, you'll have to check out a reference to see everything. These are examples of how to define colors. And then certain properties have special keywords. Other ones will use lengths or a combination of them. One important thing is that different elements can have their own specific properties, but you won't get an error if you use a property that's misapplied. Okay. And we've got the obligatory mention of a box model, which describes the sizing. You can look at that information later because I want to get to JavaScript. Again, just the amount of knowledge you need to cover everything is vast. So another thing that you might notice is the actual CSS file has a lot of repetitive stuff. You've got curly braces, semicolons, colons, and all that kind of stuff, and you can't nest these statements. So I've got nav button dot dot, nav button dot 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 shown, nav button dot dot colon hover, and those all have to be separate rules. So there are languages that people have made to that can be pre-processed and turned into CSS. They have things like constants, nested rules, conditional logic, include statements, so you can include one CSS file in another. Examples are stylus, Sass, and less. Stylus is my preference, but Sass is very popular with Ruby on Rails developers. Okay, so unfortunately, we're not going to get too in-depth into JavaScript, but JavaScript is the scripting language of the web. Thought I fixed that link. Yes, I did. Okay, so JavaScript is the scripting language of the web. Browsers don't actually interpret other languages that are Turing complete, but other languages can be converted into JavaScript using various tools. The key features that I think of with JavaScript are it's got a C-like syntax, which means curly braces and semicolons. The variables are, it's got a function-based scope and lexical scoping. So that defines, scope is all about where you can access certain variables. So when you start a function, that creates its own scope, and because it's got lexical scoping, that the contents of the function have access to all of the variables in its parent's scope, where it's been defined. It's got dynamic typing. It's got objects, which are basically just dictionaries, key value pairs. And then it's got functions as first-class objects. And because of the functions and function scoping, they get used a lot. The latest standard adds syntax for classes, template strings, kind of like triple quotes in Python, but also with expression substitution that you'd find in Bash. You've got block level scoping, which is surprisingly useful, and modules, which aren't currently implemented in many browsers. So there are various primitive types. Boolean, null, undefined is actually a very important one. It is the value of any variable that hasn't yet been assigned a value. So you end up comparing and checking for undefined a bit more than you'd expect. Number is any number, and it's always a floating point. So sometimes it's effectively an integer until it turns into a floating point. And then strings are also first-class types. Then also notably are functions and arrays, and then general objects. And there are a whole bunch of different objects that the browser gives you as well. Declaring variables. So I'm going to be using strict JavaScript for all of this. Less strict JavaScript, you don't actually have to type in var all the time and semicolons, stuff like that. But it's a good practice to prevent errors to use strict mode. So for instance, variables can be declared with var or let. So var is the most backwards compatible one. It's the one that involves lexical scoping and functions and everything like that. So we can define a new variable x, which equals 1, a number. We can have a string. Var u, because we haven't assigned it any value, is undefined. Var f equals function. That's one way of defining a function. And then O, and you've got the JSON syntax for creating objects, which is curly brace and then property name colon value. Property name colon value. Okay. And then let is for block scope, which is good for loop variables. So let's try this one out. Okay. So if I go into the console, also in the developer tools, this is a JavaScript console. So I can, for instance, type in console.log. That's the equivalent of print in most other languages. And it'll print out hello world. And beside it, it'll tell me where that was outputted from, logged from. And then undefined is the return value of the log function. So if I've copied in that for loop, so the for loop, if we look at it, says for let I equals 0. This is, if you've done C programming before, this should be very familiar syntax. You've got your initial value, semicolon, the condition on exit, and then semicolon, and then how you change the value every loop. And then a code block, which has the curly braces around it, console.log I. So this is just a loop that counts from 0 to 9 and prints out the value of I. And then afterwards, I'm trying to log I. So in the loop, got all of those outputs, and then an error, I is not defined. Now, if I do this and change it to var, then it prints out 10 because I equals 10 afterwards. Okay. I'm also just going to run this because it comes up in demos later. Okay. Good. So functions are one of the most important concepts in almost any programming language, but they're especially important in JavaScript. Functions can be anonymous. So you declare a function with a keyword function, and then an optional name, open parentheses with the arguments inside, or parentheses where the arguments get placed, and then a block of code, which is what's actually evaluated. So in this example, I've repped the function in parentheses, and then afterwards I call it using open and close parentheses. And if I run that, it will just print hello world because I ran it right away, but I can't actually access that function again. You can also name them throughout the current scope. So this won't work in the console. It works in a script. It shouldn't work in the console. Oh, no, it did. There. Okay. Yeah. So you can hoist the function so that it can be called before the definition. So that's if from the using the function statement, function foo, and then it's given the name foo. So when I called foo, it did bar. And then finally, you can assign function objects to variables. So if I ran this one, then I'll get an error at the start because it hasn't been defined yet. So I try to call bar before I define the variable bar, so it's going to return an error. But if I run it again, or if I delete that line and run it, then it works fine because now bar is in scope. Yeah, so then lexical scope is actually one of the big features of JavaScript. A lot of impressive things that people can do are because of it. So in scope describes where variables are accessible and what their names are. In JavaScript, the scope of a variable is defined with var is the current function. JavaScript also has a lexical scope, so functions inherit the scope of their parents. So in this example, I define the variable x. Then I have some function where I say var x equals, and then I create a HTML element. I find the inner HTML, or I set the inner HTML in the class name, append the child, and then log, and then after running that function, I log the value of x. So what do you think the value would actually be logged to the console? Would it be an HTML element, or would it be 10? Yeah. Okay. Now, if I didn't, I'm going to copy this and run it. If I didn't have var there, then x would be redefined to be the document element. So console, so it would actually log the HTML element that I created. We'll paste that in. Okay, so it logged 10 as predicted, and then it added a slide to the bottom of my presentation, which is there. Okay. The same thing. So let you'll mostly just use for loops and stuff like that. It doesn't have as persistent scope. It's kind of the main thing.
Const would be constant, right?
Const is a non-standard keyword if it is in there. So you don't actually use const in the same way that you don't have it in Python or other languages. Other dynamically typed languages typically don't have const, scripting languages. I think I have seen const as a, yeah. Yeah. Yeah, so for instance, in TypeScript, there will be const and it'll pre-compile it and check if you've reassigned to something that should be a constant and stuff like that. But if I okay, yeah, so const works too. I can't, but yeah, I'm not sure if that is actually standard or if it's just the most part of the latest specs and how far across it's been implemented in browsers and stuff like that. Okay, so one thing you'll see is closures. So closure takes advantage of scope to just kind of wrap data inside of itself. So this is, so in this example, I can create a counter, which is a function, or so I can create a counter, and by doing that, to create the counter, I make a function, so it has its own scope inside of it, with the variable I equals 0, and then it returns a function, which every time you call it, will return the value of I and add 1 to it. Okay, so counter calls this essentially a factory function to create, and then every time you call which returns a function, and every time you call counter, it increments it by 1. So if I bring this up again, paste in the code, and I can call counter again, and it'll give me 2, 3, 4. But of course, I was not in the scope, and even though it said I equals 0, counter is completely unaffected by it. Okay. And that's one way of creating private information. I've got a bigger example of a closure where I actually create a count by function, which uses its arguments as well in this scope, but I'll skip that for now. Objects are the other super important data type in JavaScript. So an object can be defined with the previous syntax, or the syntax I showed a bit earlier, which is just curly brace, property name, and then value, then comma, and any other property names and value. Okay. So you can see I set j equals that, and the console logged an object which has name, value, x1, and then this proto thing, which is how inheritance works. I did previously create an object called O. So if I go O.name, I get some object. If I go O, call me is a function. And so if I call that function by just adding open and close parentheses to it, then I call it, unsurprisingly. And then I also have something with a key 1, so I can access it that way. Okay. Square brackets. Let's see. Oh, yes, and you can always, or at least almost always, add and reassign values. So if I go O.name equals adds, and then access it, say that way, and I can get that. Okay. Good. Methods and calling. Yeah, so this is quite detailed as well. So when you call a function, there's a special variable that's this, and if you call the function as an object property, then this is going to be in the scope. So, or then this will be assigned to the object. Okay. Great. So in this code, I've created a function f. It uses the keyword this here, And then I've created another object, foo, which has a method on it called f. Or a method on the property called method is given the value f. So foo.method is that function. Foo.method, and then I call it, and it logs out. It logs called by bar, because I've given foo the name bar just to be a jerk. Object, it logged the actual object that it was called with, and then you've got arg1 is undefined and arg2 is earth. That's because if a function argument isn't given, then it's just the value is undefined. And then I've given arg2 a default value using an or. That's a little advanced. So if I do foo method, call it with high, then now arg1 is high. But it's the exact same as using this bind method on functions. So I can bind f to foo and then call it with high. Bind takes a function, binds the value of this and any other arguments that you want, and then returns a function. Okay, and then apply is similar, except it actually calls the function, and calls the function where this is given an object, and then all of the remaining variable names or arguments are given as options afterwards. So that gets important if you're doing object-oriented programming with it. And it's something that you can potentially trip up. Conditional statements, just like in C, if, and then the condition has to be in parentheses, and then you can have code blocks or just a single statement. And there's also a switch case. It's if, else if, and else. Everyone that talks about JavaScript warns about casting when you compare values. So if you use 2 =, it will cast to compare values. So 12 equals true gives the value true, because 12 is not 0. Wait a minute. I did test that. It's always embarrassing. Anyway, so most of the time you'll use triple equals because it doesn't do casting. So if you want to make sure that something is specifically null and not just false or something like that, you'll use triple equals. And then loops. So there are while, do while, and for loops. I'm just going to go over for loops because they're the most common, and there are 3 special syntaxes associated with them. You've got for in, for let I in shopping list. You've got for let x of shopping list, and then your classic C style for loop. So I'll copy this code into my console. Now, so I create an array called shopping list with those elements in it. If you've done lists in any language, it should be familiar syntax. And I've also added a property title to this array. because arrays are just objects and you can add whatever properties you want to them at any time. Okay, so if I do for I in shopping list, that I, as indicated by using the letter I, is actually an index. So it's just going to give me the property value. So the properties on shopping list are 0, 1, 2, and title. If you use an of in the for loop, then you get the actual values. But it has to be an iterator, an iterable object. So if I type it out, then I'll get banana, apple, and bread, but not title, because title isn't part of the iteration scheme, because it wasn't given as one of the elements in the array. Okay, so one thing, if you're coming from, say, Python or a lot of other languages like that, the for of syntax behaves most like Python's for in, whereas for in just gives you the actual property values, or property names, not the values. Okay, so I'm going to finish off with a little looking at interacting with the DOM. Okay, I've got, if you do, so my example for this is actually just the slideshow I've created. Or the app. Okay, so as a little warning, I've specifically made this as not a good example of how to actually structure your code, because there are weird things with scoping, and I'm specifically demonstrating strange things in scoping and bad choices. So, so the first thing I've got is use strict, just to tell it to be strict mode. If you have a statement which is just a string like that, it'll make sure you use semicolons and declare all your variables and have proper scoping. Okay, so then, and I've got these things defined in my global scope, and the start slides function will set them to the argument values when it opens, because that's a kind of stupid thing to do, but it makes it easier to introspect. Okay. Wish this had syntax highlighting on it. So instead, I'm going to look in sources. App, slideshow. Okay. Good. Okay, so when start slides is called, it first does an XML request. So we create a new XML request. We set the open value, and then we send the request. And then here's the key: is because requests over the internet always have a delay. If you use a synchronous call, it's not going to work. So you add an event listener, which has a callback function. And then the callback function, which is given here, is what actually does the setting up of the slideshow. And I've been a little silly and created a timeout event just so that when I refresh the page, it'll show the contents before rendering it. Okay. I've got comments all over this if you want to look at it at some other point. Okay, and then, so the actual setup function is what sets up the slideshow. but it calls render contents, and it empties the navigation element and then calls gen navbar on the elements. I should also show in the index, all of this is fed by using document.getElementBy ID and content. So this finds the element with the ID content and assigns it to the value celm. And then I've got document.getElementById slide nav, and I put that into the navigation element. And those are the elements used for all of these functions. So render contents just takes the root element, which is the content element because the variable name changed in the function, clears the contents of it by setting inner HTML equal to 0. When you set inner HTML to anything, it erases all of the children in the DOM of that element, and then parses the HTML, creates a new DOM tree, and splices it in there. So the easiest way to just clear a section of the DOM is to set the inner HTML to 0, or to empty string. And then it uses a for loop for let elm of and this make slide elements function, which I'll just tell you returns slides that are already created. For each element given by this function, it will append that to the content element, and then it adds the class. So we go root element dot children. Children is all of the HTML elements. We ask for the first one, which is the 0th element. Then we ask for its class list property, and then the class list has a method called add, and add will add whatever class we give it to the class list. So that's how we show the first element. It goes crazy. Going to finish this. Yep. Only half an hour late. Okay. So the meat and bones of it is select slide. It's a function which takes the slide element. It uses the slide element to find its parent. It changes every slide in the whole thing to remove the class shown. That tells the browser not to show it because in CSS rules, I've said show, I've given anything with that class display none. And then it takes the slide element that we want to show, it adds show, and then it does other stuff to update the navigation bar. And it updates the URL with a hash so that I can track the position that I'm in. Yeah. Okay. So I think I should wrap it up there. Should have wrapped it up half an hour ago, but oh well, it's a large topic.